Okay, I'm sharing my screen now. Let me know when you see my screen. Okay, can you see my screen?
Yes.
All right. Okay, we are a bit behind, but I'm just going to do a recap, start from beginning, so we can follow from this very first code. In the last class, I talked about keywords, and I said keywords are reserved words that are used to perform some operation. And I want you to think of keywords as sometimes or words that are specific to a language. They do something in that language. For instance, if you have a dog, there are some words that you can say to this dog that that'll make the dog pay attention. For example, you could tell the dog sit. So sit becomes a keyword to the dog because every other thing you say the dog may not understand, but you say sit, the dog understands, or you say attack, or you say come, the dog will understand. So same thing applies to programming languages, even query languages like SQL. So there are some words that are special to this language. And the two most common keywords in SQL are select and from. Let me use my pointer. Okay, so select and from. So the select keyword indicates which field should be selected. This is where you can choose the columns that you want to see in your query output. So you can pick the columns you want to see, and from keyword indicates the table in which the fields are located. In your database, you can have multiple tables. So to know the exact table you want to analyze, you use the from keyword, and then you now impute the table name. So this is the syntax. In this first example, you're just selecting only one column, and then you specify the table you're selecting it from. So select the name of the column from, then you pick the table name. At the same time, you can also select multiple columns from a table. So it's not that you are only limited to selecting one column. You can select multiple columns too. You just type the column names and you separate them with a comma. So you separate commas and you still have your from my table. And then there's another way. If you want to view columns in your table, you can use this asterisk. This asterisk is known as a wildcard. So it's in this case, it's specifying that you want to view all the columns. If you are analyzing a database for the first time, you may not know the specific columns that are there. So what most people do is just run this. They pick the table name, then they run it with asterisk, so they see all the columns that are there. And then once they are familiar with the columns, they can now maybe pick the particular one they're interested in. Okay, so let's do this quickly. Postgres. Right, so I'm here in pgadmin 4. So there's the remote server, the one that we're all connected to. Hopefully, then I have my local server, which I've already set up. But I'm going to use the remote server. If you've set up the local database, let me open it. You can use anyone. So the data here is still the data here. So I'm closing this. Let's use the remote one. Right, so what I'm analyzing is the films database. So that's film. So anywhere here you can open a query to. Mine is already open, but let me go through the process of opening it again. So to open this, anywhere around film, you can right click and select query to. Sure, you'll see film here indicating the database you are querying. Right, so let's see all the tables. First, check schemas and then tables. This will show you all the tables in this database. In this case, we only have 4. So let's say I want to view all the columns in the films database. I mean, I can actually maximize this and check the columns. So I know there are 9 columns. Let's say I don't know that. I just want to view it here with code. What I can do is select.
Sorry, sir. We've lost you, sir.
Okay, coming.
You're moving too fast, Mr. Ini. You're moving too fast.
Can you see my screen?
No, I can't see your screen.
Okay, I don't know. It disconnected the whole screen sharing. Let me share it again. I don't know why that happened. How about now?
It's back, sir.
Yeah.
All right. If you have a question, you can just go ahead because I'll be able to see your hand raised up. Okay, I was saying if you want to view all the columns in a particular table, you can start with the code. So I'm going to go again. So think of this like you're talking to a database. Maybe database is a person, but to communicate with it, you have to speak its language. And in this case, the language is, hey database, I want to select all the columns from the table films. So you're using this asterisk to say you want to view all the columns, and you're specifying the table you want to view it from, films. Okay, I'm going to run this by clicking on execute. Okay, so this is the result of the query, and here you can view all the data. It's showing us all the columns: ID, title, release year, country, duration, and it stops at budget. So let's say we want to view another table. Let me use the people table. All I need to do is change the code here from films to people. So I'm telling the database, okay, this time I want to view all the columns in the people table. And we get the different results because this is just showing us everything in the people table. We have ID, name, birth date, and death date. So we can see all the columns here in the people table. Right, any question so far?
Yes, Mr. Ini, good evening. Why
Good evening.
adding the semicolon after the people? The last time you taught us, it wasn't there. It's just from maybe people or from film. I can't remember
Okay.
if, yeah.
All right, that's a good question. And SQL, if you want to end a statement, like you want to show that you are done with that statement, done with that command, you use the semicolon to indicate that you're done. It's like a full stop when you're speaking in a normal language, where you use full stop to end the sentence, and then people know, okay, you're done with that statement. So in this
Okay.
case, whether you use it or not, your code is still going to run.
Okay.
So as good practice, you can use it just to get used to it. Okay, so any other question? All right. Let me run this again so we see the other ways of selecting the columns you want. All right, so this time, let's say we just want to view the title and release year. All we can do is type in title, comma, release year. So you're telling your database, okay, I just want to view the title column and the release year column. Don't show me any other thing. Those are the two columns I want to view. And when you run it, your database is going to understand you're like, oh, okay, he wants to just see the title and the release year column. And this is the output, only title and release year. Okay, so let's go to the next part. The next part is aliasing. So aliasing allows you to give columns or tables alternative names for easier reference in queries. Let me explain what this means. So let me go back. So you see this is your query result. Sometimes you may not want this to be the output. You don't want this to be the title, like the output. You don't want it to be written as title. You may want to use another name. Maybe you want to use movie title, or this one you may want to use release date, anything you want to use. Aliasing can allow you to modify the column name of the output. So one thing you should know is that aliasing only applies to the result. It's only going to apply to this result here. It's not going to modify the original data. I'm going to show you how to do it. So this is the format for aliasing. You can use this keyword known as. So select the column, and then whatever you want the column to be, the new name you want to give the column from my table. Let me do a demonstration. Still using this example. So this is select title. What if I don't want this to be title? What if I want it to be movie title, like showing here the output? Because by default, the title it shows in the result is going to be what you have here. That's why it's still the same. So in this case, I want the output to show movie title. Now I'm going to use this keyword as, and then the new name I want. So movie title. I can do the same thing here. Maybe I want this to be called release date in the output. All right, now let me run this. And now you can see that we've been able to successfully modify the output, the results title. So instead of showing us title, we get movie title and we get release date. Now the purpose of this is to make the resulting data more descriptive. For this particular example, there's no need, because even if we use title and we use release here, people will still understand what the data means. But when we get to other examples, other analysis we will be doing later, you will see why aliasing is important, because you need to give maybe you perform some kind of calculation where you add all the data together. You have to give it a new title to describe what that column means. But for now, don't worry too much about it. I just want you to be aware since it's part of the basics. Okay, one more note. If you choose not to use this keyword as and you leave it this way, Postgres is going to understand that what you're trying to do here is aliasing. So you can use it without the keyword as, but I usually encourage people to use the keyword so when they are looking at their code, they won't get confused, because looking at this now, it may be confusing to someone. Let me run this to make sure it works. Okay, so it gives us the same output. Again, I usually encourage people to still use this so they don't get confused when they're looking at their code, because when you see this, you just remember, okay, yeah, the person is trying to do aliasing, just trying to give it a new name, give the result a new name. All right. Now, the next part is getting distinct values. And so if you want to analyze a particular column of your table, you may find out that there are some duplicate values. Some values may repeat itself over and over again. And let me give an example. Maybe you have a country column and you want to find out all the countries that are there in your data set. If you should just select country, let's try this now. So we actually have a country column in this film. If you should select country like this, you see that some values are repeating. You have USA repeating 3 times, Germany, yeah, USA all true. But what if you want to find out the unique countries, like all the countries that are represented in your data? This is where the distinct keyword comes in. So distinct, it allows you to get the distinct value, allows you to get the unique values that are present in a particular column. And this is something you can apply when you're analyzing categorical data. Categorical data, that's data that contains categories, like the language. You want to know the unique languages that in your data set. Another one is country. You want to know the unique countries. Maybe gender, you want to know the unique ones there. The other example. So let's try using the distinct and let's see the difference. Because this is a practical stuff that can come up in real life analysis where you're trying to know, maybe your company, they want to know, they give out a survey form for people to fill, and they want to know the number of countries or number of countries, unique countries that filled this survey, that the survey form got to. So you can use this select distinct to get the unique values. And now this is the output. We can see all the unique countries represented here without any of those duplicates. So we have Soviet Union, Indonesia, Italy, Cameroon. I don't think there's Nigeria here. Please surprise me. Okay, there's South Africa in this data set. Maybe no Nollywood movie in this data. So this is how you view the unique values. Let's try something else. Let's look at the data set again. Okay. So these are other, let's see the categorical variables. We have country, we have language, we have certification. So if we want to view the unique languages, because we can see German, we can see English, are there other languages here? To find out, that's why you use distinct. So in this case, let me clear this and start again. So you can clear your queries and start again. So you just get used to the whole format, the whole flow, since you're new to it. So in this case, I'm talking to my database. Okay, database, I want to find out the unique. So I want to find out the unique. Since it's unique, I remember distinct. Distinct is the keyword. The unique language is, so the column name is language. So where do I want to select this column from? From the films table. So let's check it out, run the code. Okay, now I can see the unique languages. Here there are 48 languages represented in this data set. Danish, Greek, okay, there's none. So this is like probably a missing variable. And Swahili, Japanese, Spanish. Cool. So this is how you get the unique count by using the select distinct keyword. Okay, so in this other part, I showed other examples. We've done this, the countries, the language. The only one we didn't do was the certification. Let's try certification. So the reason why I'm doing this is so you get used to it. You clear it again just so you can get used to the pattern, because in SQL or programming generally, you just need to practice a lot so you get used to it. So let's start again. We want to find the unique certifications. So select, yeah, since I want to get the unique, I don't just want to view the particular, that column certifications, I want to get the unique values in it. So I use distinct. And then the name of the column, certifications. Where am I getting it from? From the films table. So from films. And then we run it. Okay, probably. So this error now, it's saying the column doesn't exist. Maybe it's a spelling, I think certification. Okay. So you get an error if you don't use the correct spelling of the column name. Now we can see there are 13. If you exclude this null means it missing values. So there are some missing values here. So if you exclude this, there are 12 unique certification for the movies. Okay, so this one is an exercise for you to try, and this is how we're going to do it. I'll help you type the code. You tell me what to type to answer this question, and I'm going to type it. I'm just going to follow you. So this part is all you. Don't worry, all you cannot contribute. We're doing this together. I hope you type it. So the exercise is to get the different types of film roles from the roles table. Get the different types of film roles from the roles table. Let me try this. Get the okay, so this sign here is for comment. Maybe you want to document what you're doing in your code. So you use 2- in SQL. So SQL is going to ignore this line of code because it's not for SQL. It's actually for you. Maybe you want to know what you're doing or what that SQL code is actually doing. So you can use this hyphen and then type in what you want as your comment. And it's usually good practice, like when you're doing programming, to use comments. Okay, so you guys can start. How do we solve this problem? I'm sure get the different types of film roles from the films table. Okay, from the table. Right. How would you approach this? Don't worry. Feel free to make the mistakes or say rubbish or anything. We are learning. So part of the whole process. of learning is to make the mistakes as much as you can, because you learn from those mistakes. So anybody, you can all try. Let's do this. Come on, guys. Any
Okay.
attempts,
Let me
just try
try.
to do something, even if it's wrong, doesn't
Can I
matter.
try?
Just yeah, try.
Okay. It says select
Okay, select
this distinct
distinct
rows.
rows.
Then the next command from films.
From films.
Yes.
Okay, I'm going to run
Is
this.
it
Okay, so the error is saying that rows
So it
doesn't
should be from
exist.
rows table.
okay?
Okay,
It should
from
be
rows
from
table.
rows. Yes.
All right. Okay, we are having this weird output.
I think the issue is select distinct theme rows.
Is it? What is the issue?
Yeah, select distinct and specify
Okay,
the theme rows. Theme rows, not just rows.
film rows.
Yeah.
So film.
Then
Is it
from
film
theme.
rows or
Yes, theme.
is there a
Yes.
semicolon?
No, there's yeah on underscore. Yeah. Then from theme.
From film.
Yes. Then semicolon. Then you run. Let's see.
Okay. This column doesn't exist. Right. So since it's our first exercise,
Okay.
or does anyone
Can
else
I
want to try?
try? Coachini,
Please
can I
try.
try? Hello?
Yeah, try.
Okay.
Yes.
Okay. Let's try select distinct row as in ROL without the S. Can you
Okay.
hear me?
Yes.
Okay, then from rows. So the second one, the from now has S, that's rows. But the
Okay.
first one is rows, the second one is rows, yes.
All right. So like this is okay.
Yes.
All right. So I'm going to run this. All right. Cool. Well, this is it. You got to try it. So congrats. And let's do this together. So in this kind of situation, they're asking you to get the different type of film rows from the rows table. Now you're working with the rows table and you may not know the kind of data that is there in the rows table. So the first approach, like if you're confused, is to just view all the columns first in the rows table. So select all the columns from this is the rows table. They're asking the question. So rows. So let's view this. All right, so we're seeing the different columns. We have ID, we have film ID, we have person ID, and we have row. And they're asking us to get the different type of film rows. So the column that has that is this row. because looking at this, we're only seeing two types of roles, director and actor. We don't know if there are other roles like maybe makeup artist or stuntman or anything. So we want to get the different type of film roles. So to do this, we are sure that there's a column called row, and it's in the rows table, like what she said. So what we can do is the distinct, because we want to get the unique values in this column, in this row column. So select distinct row from the table rows. And that's how we got here. So just want you to see how you can approach this question step by step. Well done on the exercise. You guys are learning. So you see, another reason why the exercises are important, just allows you to learn, make the mistakes. See, in programming, you need to make a lot of mistakes. Yeah.
Okay, when you imputed select to get the total schema out, we added asterisk. We know asterisk is all, but the asterisk
Yes.
was a bit distant from the select. I was always thinking that the asterisk must be immediately after the select and must be with the select.
Okay, you mean like something like this where it's far?
I was thinking the asterisk should be immediately after the select, but I noticed that the one you used was a bit far.
Okay, there's usually a space after it. So select space.
Okay, like
the
one character space.
Yes.
Okay.
Is it two? Mr. Ini, is it two line spacing or one?
One space.
Mm-hmm.
Although I think something like SQL won't throw that error, but there are some other programming languages, things like Python, that's sensitive to spacing. But even if I know this will still run, but just use one space so your code will be reasonable to look when someone sees it to make sense.
And I noticed that in this particular one that you are using now, you have not added semicolon after the second line from rows. Have you added?
Yeah, okay.
Okay, the semicolon is there.
It's going to work whether you use the semicolon or not. So the semicolon is just a way to specify that you are done with that statement. You're not adding any other code again. So if you use it or you don't use it, your code is still going to run. Okay. So any other question? All right, let's check the next thing.
My question will take the class back, but I will after the class. I'll ask you tomorrow. Let's just continue. Thank you.
All right. So the next part is to counting records. So you have a table and you want to count the total number of records that are in that table. Total number of records that are in that table. You can use a function known as count. So count is going to let you know the number of rows in either in one column, in one or more columns. I'll explain what this means, but let's do this example first. So this example, this code you're seeing here, so this particular code, what it's going to do is it's going to give you the number of rows in the people table. You want to find out how many people exist in your people table. So this is the syntax for doing it. Select, count, and you put asterisks in the count and from people. So let's try that code. Now your goal is to get the total number of people in the people table, and to do this you use the count function. So select count, then inside the brackets you add the asterisk, and then from people I'm just going to add the semicolon. Okay, so this gives you the total number of records that are in the people table. And now you have the output as 8,397. So this is the total number. Let's run this first without the counts. Let's just view all the columns, all the records there. 8397 was all we got in count. Right, so this is the table. If you check down here, you see it's 8397. So those are the number of records. Like this is the first record, second one, then you know there are over 8,000 records if you keep going down. All right, so let me go back to this count. Now notice something in the result. The result has the title as count. So if you're giving this to somebody, the person may not understand what are you counting because the column name isn't descriptive. So this is a perfect use case of using aliasing. So I can say as maybe people count count of people. So I want to rephrase this column name and give it something better. Let me run this. Now this is more descriptive. Someone will see this and be like, okay, this number here, 8,397, represents the count of people. So this is why aliasing is important. Okay, that's something else I want to mention. Yeah, let's go to the next slide. Now, see this, the count asterisk tells you how many rows are in a table. It is going to tell you how many rows are in a table. So there's something else, this other part. However, if you want to count the number of non-missing values in a particular column, non-missing values in the particular column, you can use the count on just that column. I'm going to explain this now. So this is an example. You want to count the number of birth dates present in the people table. There's a column known as birth dates, and initially we're using asterisks here, but you can also, in place of the asterisk, you can actually put in the particular column you want to count. In this case, we are putting birth dates because in this example, we want to count the number of birth dates present in the people table. I'm going to explain the difference between this and this soon, but let's just check the birth dates. Normally you will just come and edit this, but let's start again so you get used to the code. Reinforcement learning. So let's select count. There's a column there known as birth date. I want to count the records in birth dates, the non-missing values from people. Let's run. So it's 8397, and now we're seeing the count here as there's a difference. This one is 6,152. What happened? When we use count asterisks, we were getting 8,397. But now that we're using birth dates, we are getting something lower. So what's the difference? This is the difference. Anytime you're using count and you put in the column name, what count is going to do is it's going to count the number of non-missing values. Non-missing values. Now to understand this, let's actually view the birth date column so you know how the count is working. This is the column. You find out that there are some missing values, missing value, meaning the person, they didn't input any data in this particular place, so it's empty. It's empty. So what count is going to do, it's only going to count the places where there are values. It's going to ignore all of these missing values. So it's going to count this way: 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how count birth date is going to work. That's why we had 6,152. So this part is important. If you want to count the number of non-missing, some non-missing, a place where there are values and the values are not missing for a particular column, you can use count and just that column. So this part is just going to count the number of values in the birth date column that are not missing. But count asterisk is going to count everything missing, whether it's missing, whether it's not missing. It's going to count everything and give you the total records that are available. But if you specify a particular column name, it's just going to count the ones that are non-missing. So this is something important. Just take note of it. In analysis, some people forget difference. Okay, let me go to the next slide. But in this one, is there any questions so far or any confusion? Because it's one important part. So no question? All right. Not yet. Good, I like not yet. I'll take not yet. The next part is, now we're going to combine the two stuff that we've learned. We learned about distinct and we've learned about count. So it's a common practice of combining these two. When you want to count the number of unique values within a column, you can make use of count and distinct. You can join them together. So this example here is we want to count the unique birth dates found in the people table. Let me read that again because it sounded confusing. We want to count the unique birth dates in the people table. You know, people can have different birth dates. So we want to know how many people, we want to know the unique counts of the birth dates. Let me just use this example, then I'll explain with another example. I'm going to clear this. I know it's tough work, but let's just clear it and start again. So I want to count the unique birth dates in the people's table. So you can use select, count. To know the order, you can actually say it. I want to count comes first, the unique. So I know that's distinct. The unique birth dates. So that's the column name of people in the people table. So the table name from people. So how many unique birth dates do we have? And that's 5,398, the unique birth dates. Let's use another example. Let's view the, I think there should be names. Is it names? Let me check. And just come here, people, column. Okay, so name. Yeah, so there's the name column. We can also calculate the unique, check the unique name, the count of the unique name. So what are the number of unique names in this? I don't think we're going to get, I think we just get 8397 because no two people have the same exact name. So let's go to the film table. Let's go to the film table. I want to use something that is a bit practical. So again, let's view all the columns in our films table. Taking too long. Okay, let's go back to the country. What we're checking before, we checked the unique countries that were present in our data set. Now, if we want to find out the number of unique countries, instead of just showing the unique countries, we want to know the number of unique countries. That's when we can now combine count and distinct. So count, distinct, and then the country. This will tell me how many countries are represented in this data. So we have 64 countries, 64 unique countries here in this data set. Cool. So that's how you can combine the count and distinct. Okay, because of time, we're just going to pick one question except number one. So guys, pick a question, just one question, then we can move on to the next stuff for the exercise. 2, 3, 4, 5. Okay, I'll pick one.
Can we do
Or
five,
do you want
sir?
to pick
4.
5? We've already done 5. Nice try. Okay, count the number of non-missing. Wait a minute. We've done most of this.
Yes, we've practically done everything
Yeah,
apart from language.
except language.
And the
Yeah,
last
so do you want to try? Let's try language.
one. Yeah, you can try.
Yeah, so deleting this. Okay, let's go.
Select
Select
count
count,
distinct
distinct,
language
language,
from films.
Okay, let's run this. All right, so there are 47 unique languages. And again, column name is count. So let's say we want to make this more descriptive. You can use an alias and say, okay, change it from, because of this count function, that's why it's always giving it as count by default. So we can maybe use something like language count. And if we run this, yeah, change the column name for us. So someone will see this and understand, okay, this is the language count, 47, it's language count. All right. So now we're getting into week 2. This is actually what we're supposed to start with today.
Mr. Ini,
Yes.
Mr. Ini, the
Yeah.
distinct language, and is it in brackets?
Yes. Brackets.
Did you key it in or it comes up automatically?
No, you actually type the brackets.
Okay. Okay. I want to ask, does it matter if you say select distinct, then count language, or it must be select, count, then distinct language in brackets? Does it matter how you
Yeah, it matters. The other matters. Select, count, distinct. So I was like, if you want to remember, just actually be saying it like you're talking to the database. And you can be like, okay, I want to select. Okay, I want to count. I want to count. Count comes first. I want to count the unique languages. So you're like, okay, I want to count the unique, distinct, same thing. Think some other distinct language, some other database management system use unique as the keyword, but for Postgres it's distinct. So you want to count the unique or you want to count the distinct language. So if you say it that way, you will remember the order.
Okay.
So that's one thing that can help you. Let me zoom in a bit. Okay. Yeah, so
Please, Mr. Ini.
yeah.
Please, I was somehow late, so I couldn't log in on time. I don't this rows table and the films table. How do I get it? I don't know. I don't have it though.
Did you connect to the database?
Yes, I did.
Okay. So from here, what you're doing is you open the hell or the name you used.
Yes.
And then you see databases drop down.
Yes.
And then films, which is all we're analyzing. So maximize it.
Okay.
And the next step is schemas.
Okay.
So under schemas, public.
Okay.
And then you have tables. So you can check the tables you have here. Have you seen it?
I will try it. I'm using another this. I'm learning. I will go through the recording again. Just
Okay.
Thank you.
You're welcome. Yeah, this is actually what we're supposed to start with today. Please, can you mute yourself? All right, thank you. So with two, this is data manipulation with SQL, where you actually start to manipulate the data. And the first thing we're looking at is how to filter, and we're filtering numbers here. So sometimes you may want your query to only show rows that meet a particular criteria. What we've been doing since, it's showing when we want to select, it shows us all the records, everything. But sometimes you may just want to view the records that meet a particular criteria or some rule. That's where filtering comes in. A practical example is maybe you want to view all the movies that came out in the year 1960. You want to see all the movies that came out in 2020 or something. So what you can use to do this, there's another keyword which is known as where. This is what you use to filter. So the where keyword allows you to find rows that match a specific value. So now you can search something that matches a particular value. Let's say you want to find movies that came out in 1960. That's only what you want to find. So that one now is matching a specific value. You can also search rows that match a range of values. A range of values. By a range of values, I mean maybe you want to find the movies that came out between 1960 and 1970. So you have that range, and then your SQL is just going to give you all the movies that came out between 1960 and 1970, whether it came out in 1961, 1969 to show you. And then or multiple values based on criteria supplied via an operator. Don't worry, we're going to look at what operator means. So let me explain this part on multiple values. Multiple values mean maybe you want to find out the movie that came out in 1960. You also want to find out the movie that came out in 2000, and you want to find out the movie that came out in 2010. So you have three different values there: 1960, let's say 1999, and 2010. Use the where keyword to get that. And another thing is you can also exclude rows based on the criteria. This other one means maybe you want to view all the movies that came out in all the years except the year 1960. So you exclude all the movies that came out from 1960. It's also something that the where clause can allow you to filter by. Now, this is the syntax for doing it. You have the select, that's you're selecting all the columns from the films table where the release year is equal to 1960. So this syntax, this is how you use the where clause when you're filtering. In this case, we are filtering to match a specific value. So we only want to get the movies where the release year was 1960. I specify the column name here, and I specify the value I want. And equal to sign, it's a comparison operator. There are other operators. Let's look at the other operators. So we have the first one equal to. That's if the column name is 10, if the value of the column is 10. Then this other one we have not equal to. So it's either you use the exclamation and equal to sign or greater than less than. This means not equal to. So if I go back to this place where I said you can exclude based on criteria, and you want to view all the movies that came out in all the years except 1960, that's where you would use this operator. So in this place, you add an exclamation mark, and it's going to give you all the movies that came out in all the years except the year 1960. Okay, the other one, we have greater than. You want to find out all the movies that came out after the year 1960. You can use this greater than sign. For the less than sign, if you want to find out the movies that came out before 1960, use less than, greater than or equal to. This one, you want to find out the movies that came out in 1960 and after 1960. So from 1960, 1961, this operator is what you will use. Then the last one, we have less than or equal to. This one, you want to find out movies that came out in 1960 and before 1960. That is where you use the less than or equal to. Okay, so let's see an example. Right, so we want to select the film ID and IMDb score from the reviews table. So now we're looking at another table, review table, and filter on scores higher than 7.0. So let's say you're you love watching movies, but you only watch all those movies where the IMDb score is greater than 7.0, where the rating is high. And you want to find out those movies with the IMDb score that is higher than 7.0. So you only watch those movies, you only focus on those movies. This is how you can find out those movies. And clear this. So it's asking us to get some data from the reviews table. First things first, let's just explore that table. Let's see what's there. So select all the columns from reviews table. Okay, so ID, film ID, number of user, number of critics, IMDb score, number of votes, Facebook likes. The question only asks us to select the film ID and the IMDb score. So I'm going to do that here. Use film ID and IMDb score. So the final condition is we're supposed to get those movies that have an IMDb score that is higher than 7.0. So something like this one, the first one, this other one, this. So this is where we use the where clause, and the where clause is after the from. Notice if you do this and come and put where, it's not going to work because you've already specified that the statement should end here. So I need to remove this. So where IMDb score, that's the name of the column, IMDb score is greater than 7.0, then I can end the statement. So now you only want to get those movies where the IMDb score is higher than 7.0. So anything like from 7.1 upwards, that's what you want to get. So I'm going to run this code. Let's see. Now we get only two columns, film ID and IMDb score. But let's say let's view all the columns. But this condition is still going to apply. Okay, so syntax error at or near where. I think we need to use this column names. So film ID IMDb score. All right, so in this case, we can actually see that the output it's giving us is greater than 7.0. Everything is greater than 7.0. Let's check if there's a particular movie where the IMDb score is exactly 7.0. Oh, okay, there are lots of movies. Okay, cool. Let's see another example. So that one, select the film ID and Facebook likes. First 10 records with less than 1,000 likes from the reviews table. They want us to focus on the film ID and Facebook likes of the first 10 records with less than 1,000 likes. Let me try this. So I want to select the film ID and the Facebook likes. Remember, where are you selecting them from? From the reviews table. And there's a condition that says where the Facebook likes is less than 1,000 likes. So here Facebook likes is less than 1,000. Now there's something new here which you haven't seen. I did this on purpose so you just learn about it. I said where of the first 10 records, select the film ID and Facebook likes of the first 10, meaning we don't want to show all the outputs, all the records. We just want to show only the first 10. To show only the first 10, there's another keyword known as limit. So think of this as you want to limit the output you're getting to only 10 rows. So limit 10. End your statement with limit 10. So select the film ID and Facebook likes from the reviews table where the Facebook likes is less than 1,000, limit it to the first 10 records. That's basically you converting your SQL code to English. You're reading it. And it makes better sense when you read it out like that.
Sorry, can I ask a question?
Yeah.
Because naturally, if you are reading it the way the question comes, just like English, you would think that okay, the first 10 records and where the Facebook like is less than 1,000. So can the limit comes before the where?
And no, it can't. There are some rules with SQL. I think in week 3, we're going to see the order of how SQL runs the code. But just know that limits usually tends, you end it with limits. That's why you need to, when you're practicing, you get used to the SQL syntax. You know the order, like, okay, I know that where has to come after from. Even select is usually the first thing. I can't bring from up here. So I'm like select from where limit. So your questions may be twisted. So it's up to you to understand the question. Like in this case, you understand the question that they want only the first 10 row records, which means you're not coding, you know how to interpret it. Like, okay, at the end, I'm going to just focus on the first 10. So it's a good question you asked. We're going to learn more about the ordering
Thank you.
in week 3. You're welcome. So this is it. Notice all the Facebook lives here are less than 1,000. Yeah, shoot.
Yeah, let me ask a question. Like here you said limit 10. How do we know the right code to use, to actually interpret what we want to say? Normally, they say the first 10, thinking maybe you just type first 10, we run the code. How do you know when to use the word to use to run some particular codes or commands rather?
Okay. So for this particular case, you're focusing on the limit part because they said first 10.
Okay.
Now, Maxim.
Yes, yes, they said first 10, yes, and we had to convert the command to limit.
Okay. So this other part is me teaching you a new keyword because I now haven't taught it yet. I just want to bring it in case you want to limit. So the limit keyword allows you to, let me talk about it. It allows you to limit the output. If you don't use it, you may find out that the normal output, let me do this. Let's see what happens first. Let's see the original number. Okay, now you see the original number is 3,540. 3,540. So there are lots of movies that actually meet this criteria. But in
Yes,
your output,
sorry to cut you in. I really understand why you use the word limit because they said the first 10. My question is, they asked for the first 10 and the command word to use is limit. Okay, and I'm asking for other criteria, maybe assuming the question is the last 10. How do we know the exact command to use to run it so that we get the result we want?
oh, that's actually a good question. It's really good. Okay, I'm going to find out the one for last 10 because mostly when you want to limit, the limit only shows the first 10. Let's even check stuff. Yeah, actually, I like that question because if it's something like Python, in Python, the keywords you use, you can use dot head. Dot head will show you the first 10, then you can use dot tail that shows you the last. Let's check. Finding the last rows in SQL. Let's use Postgres. Oh yeah, that's okay. That's good. That's descending. When we get to sorting of data, we're supposed to reach that into this class. Sorting of data actually uses this. Let me try doing this. Normally, the usual syntax is this should come last in sorting. Let me see how they use it here. Oh, okay. We haven't gotten to that part yet, sorting. Because to get the last 10, you need to sort the data first in descending order. When you sort it in descending order, then you cannot take the limit.
Okay.
So it's a good thing you asked the question. Yeah, that's good. Let me check this again. So this gives you the first 10. So when you sort this, you can now get the last. But since we haven't gotten to sorting yet, I'll show you when we get to sorting. I hope we can actually reach that part today.
Okay. Thank you.
You're welcome. Right, let me move on to the next part. So we've filtered numbers. Yes, next thing is to filter text. So when you want to filter text, it's similar.
You didn't do the last
Yes.
question there, sir.
Yes, because of time. Okay, in fact, we can turn this to an exercise. Count how many records have. Okay, let's do this quickly. Count how many records have a norm votes of at least 100,000. Then use alias films over 100K votes. Count how many records have a norm votes. So this should still be the reviews table because there's a column there known as norm votes. Let's check. So let's go again, select historics from reviews. Okay, so there's the column norm votes, which is what they want us to find. They're saying count how many records, we are counting how many records have a norm votes of at least meaning it should be 100,000 or above. Okay, so now we want to count how many records have a norm votes. So norm votes. Let's see, normally this is going to count all the records of norm votes, which is 4,968. But we want to focus on the number of votes that have a count of that have over 100,000, at least 100,000. So we filter where the norm votes, the number of votes is at least. So at least meaning greater or equal to 100,000. Yeah, 100,000. At least meaning 100,000 is included, either it's 100,000 or it's greater. And then they've given us another condition where we should alias it as films over 100K votes. So this part as films over 100K votes. Okay, let's try running this. Right, so the other one we had 3,000 something, over 3,000. So now there are 1,211 movies where the number of votes is greater or equal to 100,000. So this films over 100K votes is just giving it a better title, a descriptive title. I think, well, this would be better as number of films over. Okay. So that's the last exercise. Yeah.
Thank you.
You're welcome.
Yes,
Yes, filtering text.
To keep adding the hyphen in between the words, or is that under score in between the words?
I don't get a question.
Why do we have to keep adding like no? There's a underscore of another dash films and those.
Okay, underscore.
Yeah.
Okay, this is part of the. This is for this one. It's part of the name of the column. If you check the column, let me open another query to tab. If you should check this, select star from reviews. It's part of the column name. The column name uses underscore, and there's something else. Like, okay, so see, this is it. Film ID. There's an underscore there in the name. Same thing with norm users, norm votes. So for the alias, if let's see what happens if you use this, it's going to the space there is going to break it. And now you have that error, so you can't like start typing okay number one. So you need something, and usually underscore is good, so it doesn't break. That space is going to break the code.
Okay.
Right. So the next part is filtering text. What we did, we were filtering numbers. So to filter text, it's similar. The only thing is you actually need to enclose the text you want to filter with a single quote. Some columns contain text, other columns contain numbers. So with numbers, we've seen how you can filter when there are numbers. So what we are looking at now is how do you filter when there are text? Maybe you want to find a particular word. In this case, you want to find all the movies where they spoke Spanish, all the movies where Spanish was spoken. So the language is Spanish. So we're filtering based on the language because we know. So the question didn't say anything about language. It's like get the movies where Spanish was spoken. So in this case now you have to think it through. How do I know the movies where Spanish was spoken? Then you check your data, you notice, okay, there's a column. Let's do this. Okay, so get the movies where they spoke Spanish. Get Spanish movies. Now, how do I actually know the movies that use Spanish? First, let me just check my data. So select everything from films. Just check this first. Because some questions may not be straightforward, so you actually have to think it through and then figure out how to go about it. In this case, get the movies where Spanish was spoken. I mean, we already know that there's a language column, but in case we didn't know that beforehand, so we check the data and we're like, okay, there's release here, there's country. I mean, in country, you may be like, okay, let me get the movies that are from Spain. That is one way to look at it. And then the better way of looking at it is getting the language itself, because some movies may be from the country USA where they could be speaking Spanish there. So using country may not be as efficient. So we have this column language and we can say, okay, maybe where the language is Spanish, those are the movies where Spanish was spoken. So that part is straightforward, which means we actually need to filter it based on language. So where is the keyword that we use for filtering? And then I put in the column name language, where language is equal to. Now, unlike numbers we just put them directly. When you are working with text, you can't put text like this. You can't leave it like this. If I try to run this, we get the syntax error. Syntax error means I'm making a mistake in the way I'm speaking this SQL language to the database. using the right format. So something in the way I'm typing is wrong, and it actually points us to the place where the error is at, this line where you have Spanish. So somewhere here. When you're working with text, you actually need to include it in quotation, in quotes, and in Postgres, you have to use single quotes. That's this part of the slide. In Postgres, make sure you use single quotes. So I'm using single quotes here. Let's run this. All right, now you can see the language, all of them Spanish. It's not giving me all the movies, it's just giving me all the movies where Spanish was spoken. Now, let me see what happens if you use double quotes instead of single quotes. It doesn't even highlight. It still gives us a syntax error. So in Postgres, you use single quotes when you're working with text. All right. Yeah, I've already done this one. So select all the movies that use the Spanish language. Next one is select all the movies made in USA. Select all the movies made in USA. Right, so to do this, I know there's a country column. So all I need to do is just to filter by country, where the country is USA. So select all the data from the films table. I'm filtering, I just want USA countries. So where the country, so that's the name of the column, country, is equal to, I want where the value is equal to USA. So I use my single quotes and I pass in the value. I can end my statement because I'm done. Now I run this query because I just want to get USA movies that were made in USA only. Right, so to confirm, I can see the country columns, country column, and everything, all the movies here are USA. So 3,750 movies are all were made in USA. Made in the USA. Of that
Sorry,
song.
I have a question.
Yeah.
So when we were filtering numbers, this select, we could not use select asterisk because it was giving us error. How come when it comes to text, it is querying?
That's a good insight. Let me try that again. Let me use release date 1999. Okay, I think maybe when it comes to text like this, the column name you're using has to be in select. That's actually a good observation. Yeah, the column name, I think it has to be here. It must be one of the columns you specify. I'm still not working. Select release date does not exist. Right, I think I'll have to find out why, but it's a good observation. Let's see if I should use this in quotes. I know. Okay, what other column is there? Film ID. Let me be sure I'm getting the column names right. ID. Okay, this one actually works. Integer. Why is release here not working? Okay, let me do 1999. Right, so it's actually working. I don't know what caused it, why that error was there before. Why we're getting that error.
Okay.
I don't know whether it's PG admin or something. But I know it should work normally.
Okay, why don't you try removing the quotes? Yes, let's remove the quote.
Yeah, let's try again. Let me use this new tab. So select everything from films where release year equals 1999. Let me know if it works on your end, because I think that stuff happened. I don't know why it was giving us that error the first time. What if I select only release here now?
Yeah.
Okay, it works. Right. Okay, I'm done with this exercise. Now this is where logic comes in, because this part allows you to do even more powerful comparison. Like, this is where you can do a lot of analysis, mad analysis, because you're checking different criteria, different conditions. So comparison operators work even better when we put them together, and we can put them together by using keywords like and, or, and between. And sometimes we use parentheses to help. We're going to see the use case where we can use parentheses to help, but let's look at these different conditions. If you're familiar with logic or Boolean, all those logic gates and or, yeah, that knowledge will help you here. So let's start with the or operator. The or operator is used when you want to filter multiple criteria. You want to filter it based on multiple criteria, but you only need at least one of those conditions to be satisfied. If one of them is satisfied, at least one of them is satisfied, then you're good to go. So let's use an example. This example is select all the movies where Spanish or French is spoken. In the question, it already told you or, so that's one good tip. You already know, select all the movies where Spanish or French is spoken, meaning you want to get all the movies where it's that they are speaking Spanish, or they're speaking French, or they are speaking both Spanish and French. So that's the or criteria and the operator, and this is the syntax of using or. So you select all the columns from films where the language is equal to Spanish and or language is equal to French. So this is how you use it, where language equals Spanish or language equals French. Sometimes it may be tempting to come and start doing this, writing it this way. Trust me, people will actually get tempted to write their code this way, because it's like one shortcut and you're faster. But you actually need to specify that language equal to, again, like in this case, where language equal to Spanish or language equal to French. So do this. Let's try this example. So starting again, we want to select all the movies from the films table where the language spoken is Spanish, or the language is French. Now look at the language column. You're going to find French, French, Spanish, French, Spanish. So it's returning both values where both all the movies where either they are speaking Spanish or they are speaking French. So this is how we can filter based on multiple criteria. Let's say you are learning Spanish and your friend is also learning French, and you guys are like, okay, let's only see those movies where they speak Spanish or French so we can improve our Spanish and our French. So this is how you can like select it, filter your data to get those movies, Spanish or French. Now the next one is and. Okay, this one is based on numbers. Yeah, so you can find the movies where the release year is 1960 or the release year is 1963. This is the syntax. Let's quickly go to the AND operator.
Okay, sorry, before we go to the AND operator.
Yes, before we
I
go
want
there.
to ask, like, since you are combining criteria, can we say something like, okay, maybe the language is Spanish or the release year is, so we are not using language, like we are using two different columns as our criteria.
Yeah, you can use that. You can do that. So let's say all the release. Let's try that. So stuff like this, just better to try to see what happens. This is 1999. Where the language is Spanish or release year is 1999. Now, okay, we are focusing on language and release year. So you see, you're going to have other release years like 1992, 1999, and because the reason why you're having that is because the language there is Spanish. And now where you now have 1999 in release year, because that's the condition you specified, it's going to give you all of that. But you notice the languages there, they are different. You have English, German, but the release year is 1999. So that's the or condition. The or condition makes sure at least one of these conditions are satisfied. Which brings us to and. Good thing you ask this question, because when we get to and, you see the difference.
Mr. Ini, can we combine more than two criteria?
Definitely.
Okay.
What do you have in mind?
Maybe let's say where language is Spanish, English, and maybe Chinese. Can it be more than two? Multiple? Yeah, more than two.
Yeah, it can be more than two. Yes. Let's say language. Let me copy this and put this again. English. Let me use German here. I'll show you a more efficient way of writing this code. But this is okay. You can use all like this. I'll show you a more efficient way of doing it.
Okay.
Okay, so language German, English. Okay, we have Spanish. Guess the Spanish is probably down. I passed Spanish. Okay, let's check the and. Now the and operator is in the and operator, all the conditions must be satisfied. So you want to satisfy all the criteria in your filter, which means this is going to return only those movies where the language is Spanish and at the same time the country is from USA. If it's all will give you all the languages that are Spanish and all the countries that are USA. But and the two conditions must match. Like for a particular movie, that movie must have the language Spanish and the country must be USA. If not, it's not going to give you anything. So in and the two conditions criteria must meet. So inside that example, we're looking for the movies where Spanish was spoken and the movie was also made in USA. Already from the question, select all the movies from the country USA. Okay, other ways they can ask this question: select all the movies from USA, from the country USA, and the language Spanish. So in that case, you know that they've already told you and in the question. First other one is, it's another way of looking at it. So select all the movies from the country USA where Spanish is spoken, meaning these two conditions must match. The movie must be from USA and Spanish must be the language. Okay, so select all from films where language equals Spanish. It can be in anyone can come first. And country USA. That's one. Okay, so there are just 7 movies where the country is USA and the language is Spanish. If you use all, it's going to change everything. If you use all, everything is going to change. The logic changes. So instead of 7, you're going to get, I'm guessing probably 1,000 and something, not 2,000, 3,000 and, okay, let's just wait. 3,700. So you see, USA or Spanish. So when it's not USA here, the language, all of this language is English. That's because the country is USA, which is what we asked for, or Spanish. I can't even find Spanish, but it's somewhere deep down. So that's the difference between or and or and.
But can we combine the two?
Combine the two? Oh, definitely. Depending on your logic, we're going to get there. Probably okay. No need for me to do this one. Okay, there's a need for me to do this one because I want to show you something. This question is asking us to select all the movies released between 1990 and 2000. So we want to get, this is part where we talk about range. We want to get movies that were released between 1990 and 2000. So for that decade, so you see the syntax, select the title and the release year. We just want to focus on these 2 columns, which is cool. From the films table, where the release year is greater or equal to 1990, we because we want between, meaning it must be from 1990 and above. Then it must also stop at 2000. Let's just code this. That's the best way to see this. Again, let's start again. So select. We just want to focus on 2 columns rather than seeing all the columns. So release here. So it's a good practice to use capital letters for the keywords. From films, we had the release here is greater or equal to 1990. So I'm using greater or equal to because I want 1990 movies to be included. And the release here is less than or equal to 2000. So you see, normally, let's ignore this other part. Normally, this condition here will give us movies that come out in 1990, 1991, 2000, 2005, 2006. But now we're using this AND operator to restrict it, that that same movie that the release year is greater than or equal to 1990, it must also be less than or equal to 2000. So meaning the results will just be within the range of 1990 and 2000, the AND operator. I think that error that we had before, it's happening again. I don't know why. But if I run it again, it's running. It's running. I know I updated my PG admin. This is the first time I'm having that kind of error, that situation. So maybe it's a bug in PG admin, the latest version. Could be. Okay, so this is it, the condition now. You notice that all the movies are within this range, 1990 and 2000. You won't get anything outside of it. 1993, 1997, 1998, 1999. Entrapment. I don't know what's about though. Like checking it out. Star Wars, awesome. Now 2000, that is where it stops. 2000. X-Men. Cool movies. This data set is just tempting. Just showing you movies you should probably see. Okay, now the reason I'm showing this is because there's a better way to do this, a more efficient way. If you want to do it this way, it's fine. I think that should be the next slide. Okay, that's not the next slide, probably the slide after the next slide. Okay, so someone asked if we can combine them. Yes, we can combine them. So this is or and operator, or and. So filter film released in 1991 or 1993, and with a certification of either PG or R. Okay, so here's the pointer. When we have many rules for our question, we put each rule in brackets. This way, the computer knows the right order to follow, or else we may not get the answer we want. So in this case, it's better to group it in brackets. The first condition is that you should filter the films released in 1991 or 1993. That's the first condition. Then the second condition is and the certification of either PG or R. Best way to understand this is just to do it. So let me start again. So let's select all the movies. Select asterisks. And from films. This is what we're filtering. Where the release date. Let's check. So films released in 1991 or 1993. Let's undo that part first. Where the release date is equal to 1991 or
To be released here.
Sorry, yeah, release here. Thank you. But the release year is 1993. So this is the first part we're done. Then the other part is and with a certification of either PG or R. So the movie certification should either be PG or R. So we have the and. Normally this is very confusing. So from this part, let's just put it in brackets so we know we are done with the first condition. Okay, so this is the first condition. Where release here is either 1991 or 1993. And now focus on the other part, which is now separated with and the certification is either PG. So this is the text, so we use PG, single quotes, or certification equals PG or R. And we can separate this other part with another bracket. So this is what you're asking, if we can combine the two. Yes, we can combine it. It depends on the logic what we are trying to filter by. And it's going to be confusing because you can see it's already long. The question is simple, but coding this, it's looking long and complicated. Which is why we have to use the brackets to actually separate it so we won't get confused. The first condition is focusing on the release year, where it says the release year should be 1991 or the release year should be 1993. We used the bracket to separate them. Then the second is talking about certification. It's long, just put tab, can break it down this way. Let me do this instead. Let's break it from the end. So I'm just creating this up so you know that this is still continuation of this other line. It won't be as if and is another main clause. It's just I'm using this tab so it will show its continuation. Let's Okay, so this is the logic. Trying to understand this, it may be a bit confusing, but if you are familiar with Boolean logic gates, you understand it. The first one, it's like this. It's either the release year is 1991 and the certification is PG, or the release year is 1991 and the certification is R. So it's either 1991 PG, 1991 R, or 1991 PG, 1993 PG, 1993 R. So here we go, 1991 PG, condition met, 1991 R, condition met, 1991 R, 1991 PG. So if we go to 1993, we expect the same thing. 1993 or 1993 PG. So this actually means a trick is if we do this without using the brackets. Let me come up here and try doing it without. Let's remove the bracket. Look, it's just look messed up. You don't even tell. You don't even know if it's saying release year and certification PG. It just looks confusing. And if you run this, computer will be confused. It won't know the order. It won't know the order of filtering. Originally, we have 57 as the total from the correct square. Let's see what we get when we run it this way without the brackets. Now, see, you see, we are getting 2,147. So the order is not really specified. It's just it's messed up. You see, we're having release year of 1960, 1964. We're having R. What other certification are we having? Still, it's confusing. Looking at it this way, it's confusing. It's not even easy to read. Use brackets. So your computer will know the order of evaluating filtering this. So with things like this, I'll just take it step by step, like we did like I did. So when you're reviewing this video, you can just see how we got to that step. So review this step by step so you don't make a mistake. It's actually fun. Let's go back. Okay, so again, when we have many rules, when the rules are many, in this case, put each rule in brackets, put each of the rules in brackets. Like this first part, we put it in brackets. This other rule, we put it in brackets. So it won't be confusing. So this way, the computer knows the right flow, or else we might not get the answer we want. So we're getting strange answers. So that's not the answer we want. But the code is still the same code and logic. So when we use the brackets, it helps us get the right order. Okay, so here's the solution. I use the bracket to make it easy. All right. So for this part, I was trying to show the between keyword. Let me go back to the previous slide. So for this, where we're trying to find all the movies released between 1990 and 2000, one way of doing that is by using this and, or you're like doing all of this. Another way to do it, which is much more efficient, is by using between, the between keyword. And this is logic. You want to get movies between 1990 and 2000 already. This between will already give you a clue that you want to get movies between 1990 and 2000. So you know you can use the between keyword. So select title from films where release year between 1990 and 2000. Yes. Any question? Okay, no question.
Not yet. Continue.
I like the not yet. Okay, so this is still part of getting data within a specific range. The between keyword can help you filter data within a specified range. For example, you want to select all the movies released between 1990. We've already seen how you can do that using and. An easier way to do that would be to use the between keyword. And in between keyword, using between, you just use between and then you specify the range. Now, this last line here, shows that the values between are inclusive, meaning this 1990 and 2000 will be part of the result. Movies that in 1990 itself and 2000 will be included in the results. So it won't be a case where you get movies in 1991 and it now stops at 1999. 1990 will be included, 2002 will be included. Okay, let's do this example first before we move on. So we want to select all the movies from the films table where the release year is between 1990 and 2000. Yeah, the release year is between 1990 and 2000. I'm showing it. Okay, so the release year is 1990. Let's check the end range. Okay, 1999. Already seen 957. It's still the same output we got with the previous query. And so this other example is to show you how you can use between, or you can combine all of them together, like we did with and or. So in you want to get the movies, the titles of movies that were released between 1990 and 2000. In another condition from Germany. So the movies shouldn't just be released within this range, they should also be from the country Germany. And now you know that the condition you are now going to add is and the country equals Germany. You can't use all year because all is going to give you movies within this range, and then to give you movies outside this range because they are from Germany. This question is asking for the movies that are within this range and are also from Germany. So that's why. Oh, exercise. I'm not doing all of that. Let's just do this one example. Yeah, a little bit fast. I'll be a bit faster now. So we're done with this first part condition where release years between 1990 and 2000. And we can move this to the next line. And then and country, Germany. We had 957. So from 957 to 16 rows, meaning just 16 meets this criteria. And mostly from 1998 to 2000. Right, so this is how you can measure all of those for and between. So this one exercise. Let's just do. We're just going to take one of this, only one, so we can move fast. This other one, you can use this to practice. This other side, you can use it to practice. But let's just do one of this. Let's go with the. Which one do you want to do? Select the title and answer.
Number two.
Number two.
Okay. Number two. Select all details for German language films released after 2000 but before 2010 using only where and. Okay, let's try this.
Yeah, and.
All right. Already. Let me go back to the question. Select all details for German, so German language films released after 2000, but before. So, any ideas? Doesn't have to be perfect. Just let's see if you can get the logic or some parts of the logic.
Okay, let's try. So to be select asterisk from names where release dates, yes. Release year is greater than 2000.
Okay.
Or okay, no, we are using and, right? This will be a bit tricky. We are not using whole. Because
feel free to experiment.
Greater or less than
Charles, I'm less than 210, no? Less than 2018. He said before. That should be less than
2010.
So 2010. Yeah. Okay.
That's release year. There's a release year before the greater than 22.
All right. So you mean release year, yeah.
And language equals to German.
So is this it?
Yeah. Let's try this.
I'll show you in a scale of 1 to 10.
50-50.
50-50. In this case, cases like this, whether you're right or wrong, also with 100% full confidence. Confident, you will confidence. All right, so since this is the criteria, German Ultra and movie range 2003, 2009. So cool, great job. Another thing is, if you don't want your code to be in one line, you can break it down. For that people that maybe did code, you can break it down like this. Still good. So we know that all of this is under the where. Great job. Your query is right. So just be confident, even if you're wrong. And let's see. So you guys can, this week, you can try practicing with this first one, this first exercise, and also practice with this. There won't be time to do all of this. We would have done it, but we are behind. And now to see if we can get a particular point. Well, let's just see. Let's just do this last part. Yeah, we're going to stop here.
Hello, Ini.
Yeah.
I hope you'll be giving us a copy of this PowerPoint document.
It's still the same link I sent last time.
No, but my own ended at that manipulations. I don't have
it's
this.
been updated. It's been updated.
Okay, so if I click that link again, I'll get the whole package now.
Yeah.
Okay, thank you. Thank you.
You're welcome.
Please kindly share the link in the WhatsApp group.
That after the class.
Okay.
Let's do this other part. Today is the start of week 2, so half of week 2, so we'll be able to keep up with the timeline of the course. And let's do this filtering text. I think after that we'll just end the class, so we can continue from next week Saturday. So filtering text, we've already seen how to filter text, but what we're doing there, let me go back, we're just filtering based on a particular value. So we're filtering based on a particular value, Germany, Spain, Spanish. But what if we want to filter based on a particular pattern? We want to filter it based on pattern, not just the text. This is where we have keywords like and I like, I like. So this can help us to search for patterns in text. And usually when we are using these tools, we use them with, there are 2 wildcards we can use them with. 2 wildcards. So the first wildcards are basically signed with very wildcard, that's the asterisk. Asterisk is a wildcard. We have other wildcards like percentage and underscore. So when we're using this like and I like to search for patterns, we usually use them with some wildcards. So percentage sign allows us to match 1 or more characters. There's a difference between the two. If you're using percentage sign, you want to match more than 1 character. Don't worry if you don't understand. As we go, we are going to see an example and to make sense. Then underscore is just for matching only 1 character. Let me explain the whole pattern filtering stuff. For example, we want to find movies that end with A, or let's say we want to find out movies that start with the letter A. Now we are not looking for a specific word. We are just looking for a pattern, and the pattern is the movie must start with A, or another pattern is the movie must end with the letter E. The name of the movie must end with E. That's a pattern. Another pattern could be the movie starts with letter A and end with letter E. So you see, those are different patterns, and we can set like now is the percentage sign and underscore in some. We're going to look at an example. So let's see, what's the difference between, so like operator is case sensitive. Like operator is case sensitive, meaning if you put capital letter A, it's not going to, even if it sees a movie that starts with A, but the movie name is small letter A, it's not going to include it. It's going to look for movies that are starting with capital letter A all through. But there's another one known as I like. I like is case insensitive. This one doesn't care about the case. It's just going to find it, whether it's capital letter A, capital letter B, it's going to find it for you. But like is case sensitive. The thing about I like is that I like is just specific to Postgres. Postgres has I like other database management tools like MySQL, which one is SQL Server. They don't have anything like I like. I like is just specific to Postgres. They have things like they have like, but they don't have I like. I like is specific to Postgres. Again, the difference between like is case sensitive, I like is case insensitive. Okay, this is a perfect example. Now you want to find out the name that starts with BER. You want to find out names of people whose name starts with BER. That is a pattern. So select name from people. Now all of these as they are filtering, so they are always in the like. So this is where you're using the keyword starts with BER because you're trying to find out the name that starts with percentage. Now this percentage sign means that any number of characters can be after the BER. Bernard, Benny's, note you don't care about the other characters. There can be one or more characters at the end, but your interest is just in the E and R. Let it start with BER. Then you now use percentage sign. Let me go back. I said percentage sign and match one or more characters. So whether you have one character here, or you have 3 characters after the BER, or you have 10 characters after the BER, you don't care. Your whole goal is just to find the names that start with BER. Now, since we are using like, it's going to be case sensitive, meaning even if you have a name that starts with small b, small letter b, it's not going to accept that. It's not going to like match that because like is case sensitive, so it must be BER. Like maybe add the I here. It doesn't matter whether the small letter B, capital letter E, capital letter R is going to still give you those results. This example now is to specify the difference between the percentage sign and underscore. The underscore is only one character. So let's say you want to find people's name that starts with EV and the name has only 3 letters, It must start with EV and it should be 3 letters. Now this is a perfect time to now use underscore because underscore is representing only one character. If you use percentage sign, it can give you more than 3-letter words, 3-letter names. It can give you any number of names as long as it starts with EV. But if you're using underscore, now you're saying, yes, it must be 3 letters. That is 1, 2, 3. But the first 2 letters must be E and V. Then this other last letter can be anything. You don't care that pattern. The first 2 words, first 2 letters EV, and the last one can be anything. So that's the difference between the underscore and the percentage sign. Percentage sign can have one or more characters. Underscore only one character. If we want 4-letter words, we can now add another underscore. So now be 1, 2, 3, 4. And let's just code this because we are talking too much. We want to find people whose name starts with select name from give me a second. Okay, select name from people where name like. So we want the name that starts with BER, and then there can be any number of characters after. We're not bothered about that. We just want the name to start from BER. Let's run this. Okay. Now we've seen all the names that match this. There are 12 names. It starts with BER, then you can have any number of characters after BER, Bernard, Benny, Bernardo, Bertrand. What if you use underscore here? None, meaning there's no value here that has 4 letters and starts with BER. Why if we go this way? Let me try this. So 4, 5, 6, 7, 8. Looking for 8-letter words. Nothing. All right, no problem. What if I search for B, small letter B, and still use the percentage sign? Now I'm getting nothing. That's because when you're using like is case sensitive. And because all the names in the database, they start from capital letter. So including the B, capital letter B, it won't match. So this is where I like comes in handy. Basically, I just use I like in case I make a mistake. I don't want my code to give me the wrong stuff because it's case sensitive. So I can just use I like and then leave this anyhow. It's going to give me something because it's case insensitive. Now this is small letter B, small letter E, small letter R. But because I like is case insensitive, I'm still going to get the answer, even though it starts with capital letter B. So yeah, you can play around with it, capital letter E and R. Doesn't care, it's case insensitive. But if I go back to using like it must match that case. So even when I have this B, nothing. So you can be using I like. Let's try the other example, EV underscore. I don't know if there's a name that is three letters. Oh, there's one, Eve. Nice. So we have a name that matches this, Eve. Notice it's only 3 letters, but if I use this, it will give me, it may give, if there's any name that starts from EV and it's more than 3 letters, it's still going to give me that as a result. Perfect example. So now I'm getting Eva, and other stuff. I'm also, yeah, this is the Eve, 3 letters. Eve, plumb. So that's the difference between the percentage sign and the underscore. Okay, let's see the last part, which is the not like. So not like is the opposite. It's the opposite. If you want to find a name that doesn't match a specified pattern, you just need to add in front of it. So you're looking for, in this case, you're looking trying to find people whose name doesn't end with RY. So you're trying to find people whose name does not end with RY. Let me still use this template. The name doesn't end with RY, meaning you can have any number of characters in front of the name. So this is where positioning comes into play with the percentage sign. You're trying to find people's name. Okay, in this particular case, you're trying to find people's names, people whose name end with RY. So we can use this pattern where we put the percentage sign in front, meaning we can have any number of characters before it, but it should end with R and Y. Let's see if there's any name on that. Okay, so now it's giving us all the names that end with RY and can have any number of character in front. That's why we're using percentage sign. So now the main question is not like we're trying to find all the people whose name does not end with RY. So now all we need to do is just use a not like, or not I like anyone. So we're going to get all the names of people that does not end with RY. Yes, so all these people, their name doesn't end with RY. So that's like and not like. Yeah, let's stop there. Okay, wait, there's one more. Okay, there's one more example. example. I want us to stop at this like example. Then from next class, we can continue using in and can do the rest from next class. So this is what we'll look at in the next class. Sorting data. Yeah, this is the sorting data part where I was trying to explain. So this will now give you the last 10 because you've started it in descending order. But don't worry about this next class. Let's do this last example, the very last one. So this one is find individuals whose name have Y as the third letter. Now this example is specific. I'm bringing this example so you now understand how you can use the underscore and percentage in the same line. So when you're trying to find individuals whose names have Y as the third letter, let me edit this. Now, because they are specific, they want Y to be the third letter. So we now have to come up with the pattern. The pattern is we have first letter, it can be any character. We have the second character, it can be any letter. Then the third character must be Y. And after that, we don't care what else comes after. It can be either one or more characters. So we now use the percentage sign. So now this example is specific. We want the third letter to be Y. Normally I can do this, but this can be any number of characters. It's not specific. We don't know if it's going to be, it's not going to give us the one at the, it may not give us the one at the third position, the third letter, because this means one or more character. But if I do this, now I'm sure that this represents the first character. It can be anything. This represents the second character. It can be anything. And then third character must be Y. After that, you don't care. It can be any number of characters after. So let's run this to see. This error is happening again. So just run again. In case you have that error when you are sure your code is actually correct, you can run it again. I think this is a bug with the latest version of pgadmin. Okay, so from our result, you can see ALY, Alicia. Now we're getting names where Y is the third character, ALY, AMY, Amy. Then see, after that, we don't care about the other characters after the Y. That's why we use percentage sign. Okay. Crystal, Brian, they all match the pattern. Okay, so we're going to stop today's class here, and next class we'll continue. I hope we can finish with 2 data manipulation in the next class. Right, so from here, any question or not yet?
I think for now everything is straightforward.
Okay, because I know this stuff, it's mostly you have to like review a lot of it, like review the recording and actually get hands-on like studio hands-on stuff. Yeah, you actually need to practice the SQL. You need to really practice the SQL to get used to it, because it's a lot. So I don't want to overload you guys. It's been 2 hours 30 minutes, about 2 hours 30 minutes. So let's stop there. Oh yes, I'm going to send an exercise you can use to practice this week.
Okay, that would be great.
Then you can also practice the slide, the one we couldn't solve, that number 3, just so you get that hands-on experience. And if you don't understand anything, you don't get the particular stuff, you can reach out in the group. I will reply when I am free, probably in the evening, but I'll get back to you. Or you can help each other. Collaboration is also important.
Okay, Mr. Ini, can you hear me?
I can hear you.
The clip you sent to us within the week, that's 18 minutes clip on PSQL. I think that's the name.
Yes.
on how to import data to a local database or something like that.
Yes,
So
your local server.
I went through the clip and I was able to create a local server. I downloaded the dataset, the coffee and the film. I think those were the names.
Yeah.
Then when I wanted to import it, it was actually like a document in my system. So it wasn't like a directory like what I saw you did. So I copied where I have something like, is it location or something like that? I copied the name there to import it to the local server, but I couldn't get any results. So like it
There was
didn't
no
import.
result.
Yes. So I don't know, is there any other way I can convert the format, the downloaded format to look like what I saw in your own? Because mine was like just like a file or like a normal document. So
Yeah, it's
I
supposed to
went.
be a normal file that ends with .sql.
Yes, I think so. I right clicked on it, went to properties and the trying to see where I could find the domain name or something so that I could copy it and paste. So what I saw that looked like it, I copied it and pasted it on the local
Okay.
database. And nothing was coming up. So,
Can you show your screen now?
oh no, my cursor is freezing. It's not very free.
Okay. You
What
can
the
send me a
issue?
screenshot. You can send me a screenshot. Yeah.
Okay. Then another thing I wanted to find out, how are you navigating from your local host Windows or screen to where your files are? Because me, I had to minimize the screen entirely to go look for the file, then come back to maximize to copy. I didn't think that
Okay.
was what you were doing. So,
You want to get the location, okay, because on Windows is a bit different from what I'm using Ubuntu. Because this one you actually need, come on, okay. You actually need to know where it is. And on Windows, it usually starts with that C drive. C, then you have the local disk. Your local disk is the C. Then you have your name, the name of your system. Then you have the user
yeah.
slash, and you keep going. If it's on your desktop slash desktop, then the name of the file, film.sql. In
Okay.
my
Okay.
case, with this, there's this trick I know in Ubuntu where you can just come here and copy. Once you copy the file, it's going to, and you go to pgadmin to paste it. To just paste uh, the part of the directory for you at once. But the reason why I went to properties is so you can see the exact place, like where it's starting from your system. So I know it's starting from home, and Afia, name of my system, then videos directory, then under there gospel videos, then under there Hillsong. But it's not giving me I still need to add the name of the file after this. So forward slash, then I copy this and like add it so to know that's the file itself. I'm not using Windows. I can't show you exactly how that works. Let me check here. I'll try pasting. So this is what it should look like. Home, and then finally you add the name of the file. That's if the name of the file isn't showing already. So mine was in desktop. So let's say this is the file. In properties, you can see the paths. You can copy this, maybe keep it somewhere. and then get the name of the file itself. But there's something in Windows, like sometimes it depends on you what you name your file as. Like see this place here, there's a space in this directory, so this won't work. This is going to cause it to break. What I can do now is, because of that space, I need to enclose it in quotes, single quotes.
Quotes, yeah, I know about the quote trick. Yeah, you just have to copy. Okay, so you actually copied the folder where the file is and also the name. Is that what you did?
I don't know if that'll work. I don't think that'll work on. Yes, that's what I did. But on Windows, okay, yeah, Windows, it will work like that too. So you also type the name of the file itself.
Okay, like the video I watched, after I copy the names and paste, am I still coming to type at maybe film.sql or something before I will run the command at the end
Yes,
of the.
because that's the file, that's the particular file you're trying to get to. You're trying to import that file.
Okay. It's okay. I'll try copying the two. Then I'll get back to you on my results. Thank you.
So, any other problem before we call it a night or a day?
Midnight.
Okay, so a night it is. All right, good night, everyone. See you Saturday. I'll send some exercises you can use to practice.
Thank you.
All right, thank you.
You're welcome.
Good night.
Good night.
Good night, Coach Ini.
Good night, Mademoiselle.